Hello, this is question 5 on January 2022 paper. It's a Mechanics 1 question about forces and friction, and I'm going to show you how you can get full marks, because this is an 8 marks question, which is a lot for just one simple question without sections. So we have a particle of mass m that is resting in equilibrium on a fixed rough plane, so that means it's not moving, and it means that I have friction under the action of a force of magnitude x that is acting on the line of greatest slope, so parallel to the slope here. Plane is inclined at an angle alpha to the horizontal with tan of alpha is 3/4, so that means I can draw my triangle opposite adjacent. So this is the angle, this is the opposite, this is adjacent, and this will be 5 by Pythagoras. So I know, for example, that sine of alpha is 3/5 and cos of alpha is 4/5, and I'm going to use that in the rest of the question. 4/5, and this was 3/5. Then the coefficient of friction between a particle and the plane is mu, and when x is 2p, the particle is on the point of sliding up. When x is p, the particle is on the point of sliding down. So for the first situation, so let's say for this situation, I have a particle on the point of sliding up means that the friction goes down, because the friction goes always against the motion or against the tendency of motion if the particle is not moving. So as the particle is about to move up, friction goes down. Then I have my normal reaction, always perpendicular to the slope, and the weight of the particle, which is m, which is the mass, times the gravity. So these are the forces that I have acting on my particle. I have one force here, the normal reaction, that is, the weight, that is not in my two main directions, so it's not parallel or perpendicular to the slope, so I'm going to resolve forces. This angle here is always alpha, so if I resolve parallel and perpendicular to the slope, I have here mg cos of alpha, and parallel to the slope, I have mg sine of alpha. Sine of alpha. And in this case, this is the first case, so case A, this is 2p. I need somehow an equation to find mu that relates all the variables that I have. So if, let me show you. If we resolve, in this equation, in these questions, you are going to always resolve parallel and perpendicular to the slope, or one or another or both. So if I resolve perpendicular to the slope, I will be able to find the normal reaction. If I resolve parallel to the slope, I will be able to find friction using this normal reaction. So let me show you. If I resolve perpendicular to the slope, and for resolving perpendicular to the slope, you get 1 mark. Force pointing this way will be the same as the force pointing that way. So R is going to be mg cos. So R is going to be mg cos of alpha, and we say that cos of alpha is 4/5, so this is going to be 4/5 mg. You get another mark here for substituting correctly. More than for the cos, really for substituting here correctly. Then, if we resolve parallel to the slope, and again this is 1 mark, so we are resolving parallel to the slope. In the first case, so we are still here, force pointing up the slope, which is x, is going to be the same that the two forces pointing down. So this friction and this mg sine. So force pointing up, which was 2p, is going to be the force pointing down mg sine of alpha plus my friction. Friction, I know when it's about to move, is maximum. So friction is maximum, and is going to be mu times normal reaction. You get a mark for using this. So in this case, if I substitute here, I have 2p. Sine of alpha is 3/5. So 3/5 mg, and friction is mu normal reaction. And I can substitute the expression that I have for normal reaction already. So this is 4/5 mg. So if you see here, I have one expression with P and with mu. M is given and G is a number anyway. So I have one expression here that relates P and mu. So what I'm going to do now is to think of the second situation. So B. Second situation, when X is P, particle is on the point of sliding down instead of up. So that means that my friction is not going to be anymore down. My friction now is going to be up because the particle is trying to move down. And again, it's against the motion. This friction is going to be the same that it was before because friction is maximum because it's about to move, is mu normal reaction. Mu doesn't change because it only depends on the roughness of the surfaces, and in this case normal reaction hasn't changed. Different is if I am add other forces or I remove forces, but I haven't, so this normal reaction is the same. So if I resolve again parallel to the slope, but in the second situation I have force pointing up plus friction is the same as the force pointing down. So in this case, this is P instead of 2P, and I have P. So P, and you have 1 mark for substituting this correctly, so for writing this equation correctly. P pointing up plus the friction pointing up is going to be mg sine of alpha pointing down. P plus mu normal reaction, and again I'm going to write normal reaction that I found before, is going to be 3/5, which is sine of alpha mg. And this is my second equation, and this is again 1 mark. So I have 2 equations, this one and this one, with 2 unknowns, P and mu, and I just need to find mu. So what I can do, well, I'm just going to solve simultaneous equations, has no much mystery. So what I'm going to do, for example, is from 2, I'm going to make P the subject, so P is going to be mg, and I'm going to open just brackets, factorize, so 3/5 3/5 minus 4/5 of mu, and I'm going to substitute in 2. So I'm going to substitute that expression in 2. So I have 2p, and instead of p I'm going to write this expression here. So 2mg 3/5 minus 4/5 mu is going to be this second part. So 3/5, I don't have space, so I'm going to move it down here. Is going to be 3/5. I'm going to factorize again this mg so I can cancel it, just is better. Mg 3/5 plus mu 4/5 of mu. You cancel mg, you cancel mg, you can cancel the 5s if you want, because everything is divided by 5, and then you have 6 minus 8 mu is 3 plus 4 mu, or 3 is going to be 12 mu, and therefore mu is 1/4 or 0.25. You have another mark, let me show you, for solving the simultaneous equations, and another mark for the for the final answer, which is 0.25. So you have your 8 marks here, and that's not a long question or too difficult. It's just when you don't have like sub questions, sometimes it's more difficult to decide what you're going to do. But that's all. Hello, if you like the video, I have a free last minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well, because the questions are identical, you just have less topics. I have other courses through the year. They are all in my website, and the link is as well in the description below. I would love to help you.